Hi guys. So this one is about a life base. It's basically a way to calculate probabilities. Um, for example, we have salary and age. These are the data points, and if this gray one is the points we're gonna predict, then we just want to know what's the probability of works or drives, right? So there is a formula to calculate the probability of this x, which is you calculate the px first. So px basically is the probability of this x, this gray points in the whole points. Okay, the probability of that, which means what's the probability of their age and their salary, all that. So it's a probability. So in this, for example, if there's 20 points, then what's the probability of this points in this location? And then P drives, which means all the green. What's the probability of the green? Okay, in the whole population, whole set. And then you need to figure out what's in the driver set. So this was drive set. What's the probability of x, which is right now in this position, right? In this position, what's the probability of that? So basically, that's what it was. And what the computer will do is they're actually gonna count. For example, probability x, then they're just gonna count. So in this area, in this column, how much points they have, and in these core points, how much point they have, so they can, figure out the probability of that. And drives the same thing, in all those points, how many points is in the drives, then they calculate the probability. Basically, they do this by counting. Okay, they count things and they simulate the probability of that. So when you import this, the salary data and the age data, and you tell them what's the training data, right? What's the dependent variable gonna be, and when you add a new data somewhere, right? Let's say if you add new data like here, right? Then they will just use this formula to calculate the probability of these points is as drives. Okay, so basically that's what it was. Back to the code, it's the same thing. You wanna import the library, get the data, and set up X data and Y data, and then you want to split the data. After you split it, and you make sure you do feature scaling. That's typical thing we do. And then still typical thing, you just get the right library. Okay, we use naive base, and we use Gaussian MB. You put the Gaussian MB created in the code, add a classifier, and then you feed this classifier to our data, so we have a model in there. So classifier become a model, and then you can use the classifier to predict the value, and you can and then we can make a confusion matrix by our tests, y test and y predict, which is the reality and our prediction. Then we can look at it. We'll see here in terms of negative zeros, we're pretty good, and in terms of 1, we're good also, even better. So that's like the case. And if you look at you can plot it and look at how it looks. So you can see here, they kind of like similar with the other method, right? They just draw a curve, no linear line in here, but the way you're doing it is by counting. So you will see some points just like in between, a lot of points in between. Okay, it works it kind of like ignored the, outliers somehow. Um, we'll talk about the benefits of this one later, but it can be nonlinear, right? It's a nonlinear ones, right? So that's this for naive Bayes. See you next.